Hello, this is Emmanuel here on Cyber Concoct, and in this video we are going to hack into a machine and then perform privilege escalation. Before we begin, there are a few things to note. Now, there are 5 stages of ethical hacking. Number 1 is reconnaissance. This is the stage where a hacker goes out and tries to get information about the target machine. So all your information gathering. This stage is also known as the preparatory stage. So this is the initial stage where a hacker goes out and finds all the relevant information about the target that is about to be exploited. Then the second stage is the scanning and enumeration. Here, the attacker makes use of tools and devices to go through a particular target that has been identified. Scanning of ports actually go on here. So a particular target machine is scanned and then viewed to see the vulnerabilities that might be on that machine. Then gaining access is the point where a hacker actually exploits those vulnerabilities that have been found from the stage 1 and 2. Then we move on to stage 4, which is maintaining access. So if a target machine goes off and it comes back, we should be able to still have our access. And then number 5 is covering our tracks. So we want to make sure that nobody knows that we have ever been on the target machine, and then we need to cover our tracks. All right. So special acknowledgement. The machine we will be using today, this one has been provided through the Cyber Mentor. So thank you, the Cyber Mentor, for providing this machine for us. Now, the IP address of this target machine is 192.168.59.6. So this is the target machine. This is the IP for the target machine. So as we go through this hacking process, we'll be touching on the 5 stages of ethical hacking that I have just mentioned. Now, what we need to do is, first and foremost, we need to make sure that the machine we are trying to hack is live. What this means is we want to make sure that the machine is up and running. And by doing this, we want to ping the machine. So if we get a response back, that means our machine is live. And we can do this by typing the command ping. And don't worry about this when you see it. It only means that I've run this command before, so you can totally ignore it. All right, so we ping the machine, and when we get bytes back, we know it's live. So we are getting some packets back. It means that our machine is live. Good. Now we have identified a target machine, and we know for a certain that the machine is live. The next thing is we need to scan and enumerate this machine. And we have a tool built in Linux that does that for us, nmap. So we can write nmap, and now this code is telling the nmap, okay, we need to scan this particular IP address, and then we want to use 4 threads. So there are 5 threads actually. 5th is the fastest, and you can be identified easily. Then -p dash, we want to scan all the ports, and then -a, we want all the information available on the machine. So let's go ahead and hit enter. Now the machine is scanning our target IP address. We'll wait for the result of the scan to complete, then we begin from there. All right, so the scanning is over, and then let's look at what Nmap has discovered. So we can see right from the top that the FTP port is open, and okay, anonymous login is allowed also. Okay, we also see that the SSH port is open, and then the HTTP port 80 is open, and then there are services running on it. There's Apache HTTP version 2.4.38, Debian running on it. Okay, so we can decide to take this from the top. So let's see what is available on the FTP, because it said here that anonymous login is allowed. So let's try. So now what we are doing is, after reconnaissance, this is scanning and enumeration. We are trying to get as much information as possible as we can get from this target machine before we exploit the machine. So let's go on and connect to the FTP server. I'm going to open a new tab here. Okay, so let's connect to the FTP server using anonymous login. So FTP, our target IP address, hit enter, then anonymous, password is anonymous. All right, so we are in. Now the next step is we try to look around, see what is left untidied, and then we can get as much information as we like. So we can ls to see, and it looks like we have note.txt here. We can get the note.txt to look at it. So we do get node.txt. Okay, looks like we've gotten the node.txt. So let's go back to our initial tab, ls, and our node.txt is right here. So what we can do is we can try to look at the content of the node.txt. Okay, so it looks like a message that has been left for somebody. It reads, "Hello, Emmanuel. Grimmy has set up the test website for the new academy. I told him not to use the same password everywhere. He will change it ASAP. I couldn't create a user via the admin panel, so instead I inserted directly into the database with the following command. Insert into database, insert into student reg number." So this looks like a creation of a SQL table, and then say the student reg number is what you use for login. Let me know what you think of this open source project. It's from 2020, so it should be secure, right? Can always adapt it to our needs. JDelta. All right, so it looks like this person here has left this information, and then there's a lot that we can get from this information. First of all, it's telling us that there's a student login available somewhere, and remember from our Nmap, we discovered the port 80 of the target machine that is open. So we are getting clues. So we are also seeing that student reg number is what you use for login. This is definitely this. So we can copy this and let's drop it in our, let's drop it here for now. Also, okay, and this looks like the password. because from the database schema here, the third entry here is for the password. So the first one is the reg number. We have an empty input here, and then we have this. But this looks like a hash, but we'll find out in a minute. So let's paste that here also. All right, so we have something that we can use to attempt a login. Now, from our scan here, we find out that port 80 is open. All right, so what we can do is we can open a browser and try to visit that port 80 to see what's available there. So http 192.168. All right, so hit enter. Apache 2 Debian default page. Okay, from our scan, we saw that this was running. We can see the version and we see it's Debian. So it's the same thing we are getting here. But then from the information we got from the notes, it does not look like we have a place to log in here. Now, what we can do is we can do something called directory busting on this website. What it means is we can go to this website and then try to look for other directories that are linking from this. So might be this slash something else, let's say slash home slash password, whatever it is. So there's a tool available on Linux that does that for us. It's called FFUF. So however you pronounce it, I like to call it FUF. So you can install it using apt install FUF. I already have it, so it doesn't hurt. You can run it. If you don't have it installed, it will install it for you. Now what we can do is we can say FFUF. Now I've gone ahead and typed this. Let me explain what is happening here. Now we are telling this FFUF that we need uh, to scan and find out the directories that might be linking from this particular IP address. And we are providing a word list. Our word list is located at user share word list, debbuster directory list, then small.txt. And then the -u is providing a URL, which is our target machine. And then we want to first, then -c means to provide it a colored scheme. So we get our output colored. And then -v is for variables, which means we need as much information as we can get. So let's hit enter and then wait for the directory busting to finish. All right, so it looks like our fuzzing is complete. And remember the -c for colored output that we specified. This is it. So now we see that academy has been identified. Also PHP my admin has been identified. So we can now go and then try this out. So we have academy. So we come here and we do slash academy. All right. So it's presenting us with a login interface. So enter reg number, and remember from the notes, it says the student reg number is what you use for login, and we have the reg number here, and this is password. So what we need is we need to enter the reg number and then the password, but we have a small problem. The problem is that the password is a hash, and then we can't enter a hash into that input. So we need to find a way to analyze this hash and then try to crack it. Now there's a tool available on Linux that does that. It's called hash identifier. It is used to identify a particular hash. So I'm going to copy it, and what I'll do, I'll come and open the hash identifier, and then we'll paste the hash that we have, and then we hit enter. Okay, so possible hash. So it's telling us that it's possible that the hash is an MD5 hash, and the good news is that this can be cracked. Okay, so these are least possible. So this is the most possible hash. So this is definitely what we are looking for. All right. So how can we crack this? Let me go ahead and quit this. Now there is also a tool available on Linux called Hashcat. Hashcat is used for cracking passwords. So Hashcat -m for the module, the 0 is for cracking MD5 hashes. Now go ahead and type the password hash in a text file, because that's what is required. We need the password hash in a text file, and then we locate our rocq text. Now, if you don't know where your rocq.txt is, there is a way to do that. I'll show you here. You can type locate rocq.txt, and then it will provide you with a list of the directory path to where your rocq.txt is. So you can use that and come here and say hashcat. Now we'll provide the hashes in the text file, then our rocq.txt. Now there is a caveat. This is computationally intensive, so it runs on GPU. And if you are using a machine that has only CPU, you might run into issues. So I've gone ahead and run this on my base OS, and then it came out as student. So the hash we just saw, this hash is the hash for students. All right, so what we can now do is we can now take the details that we've got and then go back to the login page to try and see if we'll get access. All right, so we'll come in here. What's our reg number? Okay, so our reg number is 10201321, and then from the password that we just cracked, we found out that it's student. So that hit enter. All right, so looks like we have access. Okay, it's asking for a change of password, but is this really necessary? Okay, let's look around. Enroll for course. Okay, do we have a pin code? Enroll history. Now, basically what we are doing is, from what we have, we are looking for ways we can abuse this access that we have or upload some malicious code. I think we found something interesting here. Okay, so it's basically a registration page student name, the reg number, the pin code, the GPA. It's asking for a student photo. So there could be something here because a student photo is usually a file. And if we find a way to exploit these inputs, then we might have an opportunity here. So first of all, let's try to upload an image. I'll try to upload an image of a dog. Let's see, downloads. I have a dog JPEG here. Now update. All right, so we see that student record is updated successfully. And this is the image I just uploaded. But now we see something that this is running a PHP file, right? Now, let's see if this will accept any other file that is not a JPEG or that is not a picture. Let's try to, for example, let's go to documents. Sorry, downloads. No, let's go to root, ethical hacking. Now the node.txt that we just got from the FTP server, let's try to upload it and see if it goes. Update. Wow. So we see that they are not performing any checks here. So this gives us an opportunity to try to exploit this. Now we know a couple of things already. We know that this is running a PHP file, and then that they are not performing any checks to see if the file that is uploaded is what is required. Now we can exploit this. To do this, we can then go to Google and search for, we can search for, there's a tool that we can use, but let's search for PHP reverse shell. Okay, let's go to this GitHub link. So what we are interested in is the PHP reverse shell.php, because remember the site here is running a PHP file. So we can go ahead and click this. Okay, so you can go ahead, Control A, Control C. We need to copy it. Now what you can do is you can come back to your, so we're going to create a file. Let's call it nano, let's say bad php.php. Now we want to, so let's paste what we just copied. Now remember, this is a reverse shell. So before we save, we can come here and edit this line. Now we want to put in our attacker IP address, and my attacker IP address is 192.168.595. We can keep the port the same, doesn't matter. So let's go ahead and save. Ctrl X, yes, hit enter. Now when we do ls, we should see our bad PHP. Now we want to upload this to our student profile here. So let's go ahead, but before that, let's go ahead and listen on that port. I think it's 1234. So we can come here and do NC. So now we are listening on port 1234. What we are doing is if we are successful here, then we should have a reverse connection here. So let's go ahead and upload the file. Remember we named it bad.php. So go ahead and now when I click update, if everything goes as planned, then we should have a reverse shell here. So update. Exactly. Wow. So you see that on this side we've gotten a reverse shell connection. This is wonderful. So we've been able to penetrate this target machine. So let's see, who am I? We are www-data. All right. So first part is done. We have been able to successfully exploit the target machine and gain access. But we are not yet root user, so we are limited by what we can actually perform on this computer. Up next is privilege escalation. If you have not subscribed, please subscribe and like this video.